In this video, we're going to practice some molarity problems. So our first one, if we use 278 grams of hydrochloric acid, and we want to make a 3.5 molar HCl solution, what volume of water is needed? So how dilute do we need to make this much chemical? Do we want just a few milliliters? Do we want buckets and buckets? How much volume is necessary to turn this into 3.5 molar? Go ahead and pause, give it a try, and then come on back. All right, if you're back, well, I want 3.5 moles per liter. So at some point, I need to have 3.5 moles in 1 liter. This is going to equal some other number of mole over some other liters. I have a real number of moles. 278 grams of HCl is some number of moles. So I can fill in this top bit, and I can solve for what volume would give us that same 3.5 ratio. So the first step is I need to turn my 278 grams of HCl into moles. 278 grams of HCl. Get out of grams of HCl into mole of HCl. Well, 35.45 plus 1, 36.46, if I want to round up, grams of HCl to 1 mole. We'll find that this comes out at 7.625 mole of HCl. So I have a large number of moles of HCl, way more than 3.5. We're going to need a bigger volume to make this work. So we have the moles of HCl. How do we then convert it into our final concentration? We had wanted that 3.5 moles of HCl in 1 liter. Well, now I have my moles. 7.625 moles in X liters. I need to rearrange to get X on its own. So I have to multiply by 1 liter on both sides so that I can cancel that out on the right. I need to divide by 3.5 mole on both sides so I can cancel those out. And I need to multiply X liters on both sides to move my X over. This will rearrange to look like 1 liter times 7.625 mole divided by 3.5 mole will equal X liters. I have to rearrange to get X on its own. When I do this division, I will find that X liters is 2.178. So 7.625 mole in 2.178 liters. When you do that division, what you find is that it is spot on at 3.5. So for the actual hydrochloric acid we used, we need 2.178 liters in order to obtain the molarity we want. If we gave it a different volume, it would either be higher or lower molarity. 2.178 liters is exactly the volume we need to give it 3.5 moles per liter. Well, if we go back and look for sig figs, 3 and 2, it's going to keep 2 at the end, and so we have 3.5. Realistically then, your volume answer is 2.2 liters. And so we can find what volume we must dissolve our chemical in to make a target solution. In this problem, take a 5% weight to volume solution of sodium chloride and see if you can puzzle out its molarity. We know what the chemical is, and we know the weight percent. How do you convert that to molarity? Give that a shot and come on back. All right, well, if you gave it a try, molarity wants mole of NaCl over liter of NaCl solution. Weight percent tells us that it is 5.0 grams of NaCl over 100 milliliters of solution. So I know a weight of a chemical and I know the volume it's in. I just need to scale it and convert to moles. Well, molarity wants in 1 liter, so that's really 1,000 milliliters. So that's 10 times more. what we're going to find is that, well, what value of weight will give us 10 times more? 50.0 grams. If I want to scale this up to do molarity, I need 10 times the weight because I need 10 times the volume. So what I'm really working with is that there is 50 grams of NaCl in my 1 liter at the end. But I don't want to be in grams of NaCl. I need to be in mole. And so I need to convert my grams to my moles. 1 sodium, 1 chloride, 58.44 grams in 1 mole. And so we will find 0.8556 mole of NaCl. Well, we already scaled the volume to be in 1 liter, so it's that many moles in 1 liter. 0.8556 mole in 1 liter, so this is 0.8, and we hit 2 sig figs, so 86 molar NaCl. So a 5% solution of sodium chloride is a 0.86 molar solution of sodium chloride. In this problem, we have 73 milliliters of a bottle is poured out. That bottle is 1.98 molar sodium hydroxide. So if I'd poured a full liter out, I'd have 1.98 moles. I poured substantially less. But if I had half the volume, I'd have half the moles. If I had a quarter of the volume, I'd have a quarter moles. In this case, whatever 73 milliliters, whatever fraction of 1 liter that is, I'll have that same fraction of moles. Can you solve me how many moles that is and then convert that into the mass of sodium hydroxide? In 73 milliliters of this solution, what is the mass of sodium hydroxide present? Give that a shot and come on back. All right, if you gave that a shot, well, I've got 73 milliliters, but molarity is done in liters, so I need to get out of milliliters and into liters. So this is 0.073 liters of NaOH solution. So I know what volume I'm actually working with. 0.073 liters. And I know that if there was 1 liter of my solution, there'd be 1.98 mole of my chemical. Well, my liters of solution will cancel out, and I'll be left in mole of my chemical. So 0.073 times 1.98. 0.1445 mole of NaOH. So I found my moles of sodium hydroxide in this volume, but the final question was convert it to mass. And so 0.1445 mole of NaOH. Well, I need a ratio of mole of NaOH to mass of NaOH. Add up periodic table, 1 sodium, 1 oxygen, 1 hydrogen. 1 mole is just about 40.00 grams. So this will be 5.78 grams of NaOH, which realistically we had 2 sig figs early on, so 2 sig figs at the end. This will be 5.8 grams of NaOH. In that 73 milliliters, there was 5.8 grams of sodium hydroxide dissolved. This time, we want 0.75 moles of lithium fluoride. And it's being poured from a bottle that is 0.55 molar. So I need to pour it out until I have poured enough liquid that it has brought 0.75 moles with it. Question is, what volume is that? What volume of the bottle do I need to pour out so that I have my 0.75 moles? Give that a shot and come on back. All right, if you're back, well, I know the moles I want. 0.75 mole of LiF. And there is some volume, unknown volume, that would contain that. That ratio must be equal to the concentration, 0.55 moles of LiF over 1 liter. I need more moles than is in 1 liter, so I'm going to need a larger volume. I can solve for what x is if I rearrange. I need to bring the unknown up to the far side. I need to times by 1 liter to get it off of the right side. I need to divide by the moles in the concentration in order to rearrange everything and have x liters all on its own. 1 liter times 0.75 divided by 0.55. What we'll find is that x must have equaled 1.36 for this to be true. So what volume do I need if I want to have 0.75 moles? Well, a little over 1 liter. I needed more moles than were in 1 liter, and so I needed more than 1 liter. What I find is I need, with 2 sig figs, 1.4 liters of solution. That will obtain me my 0.75 moles of lithium fluoride.